Now we need to learn how to check for heteroscedasticity in a model. We're going to use a visual test to see if there is any predictability or patterns in the residuals versus the predictions. R creates the residuals, as you know, because we use them in assumption number 3, but R also creates predicted values. It calls them fitted values. So we're going to use the code shown here, plot fit resid, comma, fit fitted, and we're going to see if that plot contains any patterns. Again, here patterns are bad. So if we see a pattern, it means there is predictability in the errors. It's better at predicting the heights of 5-foot tall people than it is at 6-foot tall people. That's predictability in errors, and that's a bad thing for this assumption. Now we're going to use R to test for heteroscedasticity. Brought up our old R code where we read in the packages dataset, created the model we wanted to use, in which case R created the residuals and the predictions called the fitted values. Let's look at those fitted values. Fit dollar fitted. Let's look at the first 10 values. Here's our command window. So it's saying that for the first observation, our model predicted that our team of delivery personnel would work for just under 7.5 hours on the first day. On the second day, it predicted just over 6 hours, and so on. So not only do we create a model where we get coefficients and significance tests, but we create predictions and errors all at the same time. So R is doing all of this work for us so that we have these things as resources, but we don't have to create them ourselves. But back to testing assumption 4, that we have no heteroscedasticity, we'll just create a single plot of fit resid versus fit fitted. That's it. So let's run that code and look at that chart. Now, as you know, I don't like the open circles. I like closed circles. So I'm just going to write a few commands that are going to change that chart. Plot fit resid versus fit fitted. PCH equals 20. CEX equals, let's say, 0.6 for size. And let's run that code. So here we are with a little bit different chart. We have the residuals on the horizontal axis. These are the errors. And we have the predicted values on the vertical axis. So we're generally predicting between 5-hour days and 8-hour days for our workers. So looking at this chart, I don't see any pattern. It does look very random, and that's a good thing. If we saw a cone, or we saw a line, or we saw some other shape or repeating pattern, we would be concerned. But when we look for heteroscedasticity, we're really looking to see if there is predictability in the errors. And here, this is a random blob, so I don't see any predictability. So this chart leads me to believe that for this model, there is no heteroscedasticity, and so we pass assumption number 4.